The purpose of today is to provide some instructional video. Hopefully we've got some customers coming in and out. They can ask me some questions pretty directly on what they'd like to see, whether it's on the unit or I've got a heat exchanger set up. I've got a little tool behind us you can't really see, but if we have any extruders hop on, I've got a feed section of an extrusion line. I've got both of our carts so people can see them and kind of have a hands-on. For anybody that just joined, we've got the cart running. It's flushing out a cooling passage on a little mold here. It's our EcoPro 360 chemical. It's non-hazardous. Reusable is a big key. It's safe to work with. So, you know, a lot of acids on the market. You've got to wear the full PPE gear. This stuff, as you can see, just dip my hands on the reply. It's very safe to work with. It's 85% water. Got it all in my hands. You can reuse it as long as you filter it out properly. I think we've got different attendees than the beginning. So we started out using this chemical cleaning tooling surfaces and various other items. And then we had a call from a customer that said, I'm putting it through a different pumping system, but it's breaking that pumping system down every 3 to 4 months. But he loved the chemical so much that he would just buy brand new 10 gallons of material every 3-4 months. We said, we'll build you a better cart. That way it withstands all the seals, which is what we set out to do. And that's how the EcoPro cart was born. We put a filter in on the back. That way users can continue to reuse it. I'm gonna flip this around so you can see it. Forget about the short lines. Built-in filter. So as this pumps out, returns back to my cart, goes through the filter before being returned to the drum on the front. So that gentleman took the very first cart that we manufactured, along with 15 gallons of material. He has since only purchased, and that was back in February, March of 2019. He has only since purchased 2 filters. Has not reordered chemical because he's still using that same 15 gallons. Air diaphragm pump versus an electric pump for safety reasons. 1, you don't have an electrical cord. The 2, if you run into a pressure block situation where something's plugged up, that pressure gets sensed back from the air diaphragm pump and the pump will actually cease operation. So you're not having a pressure build up. You're not going to pop a line and blow acid everywhere. That pressure buildup is sensed at 10 pounds less than your current supply. So right now our shop air is set at 110 pounds. If we had to run into a pressure block situation and it sensed, 100 pounds, it would simply cease operation. Another reason why we went with this, I have not yet been in a shop that doesn't have air, but it's not going to shock me if I walk into a door and somebody's like, we don't have air. I don't know why, but I've been in some pretty sketchy places. But with that, there are 2 air supply hookups on the back here. Right now, this says pump air. We've got a check valve on top, which you probably can't see from that angle. But it's just a simple little lever that goes back and forth at a 45-degree angle. The other setting is for when I go and I want to blow all this chemical back into my drum and move my air supply over to the blowout side. And in order for that to operate, I have to move my check valve over. The reason why we did that is to protect the internal components of the pump. That way you don't have users that mess it up. So if I were to move this check valve over to blowout and I'm hooked up to my pump side, the pump is not going to operate. So, but we want to protect that pump being as it's the most expensive component. So with this, average users can expect an increase in flow. I typically see about 10%. As I mentioned earlier, as little as 30 thousandths buildup can affect your cooling and your flow. I've seen some pretty pretty bad and gnarly cooling passages that haven't been cleaned in years. So when it's easy to say, you know, that you achieved 100% increase in flow when the tool doesn't flow at all. So, but it is important to take this step in your preventative maintenance. You know, it affects part performance, and with everybody going to conformal cooling now versus straight through lines, you can't just simply drill out. And a lot of times guys will take their shop air, shoot through one of the circuits and say, oh, I've achieved flow. Again, that's why it's important. You know, when people tell me they don't have any issues with their cooling lines or they're perfectly clean, I ask if I can scope. I mentioned the bore scope earlier. And you'd be surprised at how gnarly the insides of your lines look. So I'd recommend getting one of those if you can.
That number, Brian, that you were mentioning, just so everyone knows, that is an important number, and one that we stress here, that 30 thousandths of buildup on a water line reduces the cooling capacity of that line by 60%.
That was the number. Yeah, I didn't want to overstep because in my head I was like, man, that seems way too high. But
I know. You know, people can't, they don't believe that. You know, a 32nd of an inch of funk in a line reduces the cooling capacity by 60%. That's crazy, but that's why cooling is so important, and that's also why it's such a neglected area of maintenance. And you hit it on the head a few minutes ago. You said, we ask people when they come through here, how do you test? You know, when the processor comes over and says, we think we have a cooling issue because we had to add a second or two to the cycle. How do you test for that? And 99% of repair technicians will walk up with an air hose, blow air through it, hear it, feel it, and go, this is all right, and then walk away. And it's just not as scientific a way to measure that restriction as we can get with the Berger and Brown digital flow meter. So that people need to be able to use tools like this so they can quickly assess whether or not, you know, they have that cooling issue, because that is huge, 60%.
Absolutely. I mean, yeah, that's why I said in my head, I was like, I had the number 60 in my head, and I'm like, no, that's too high. And 60% of anything is a big number. But for those of you that may have hopped in a little bit late, Steve Johnson's over at Mold Tracks. They do certification courses, hot runner courses, mold texturing, a lot of cool stuff. He's got all state-of-the-art equipment in there. We just got into a shop, which I'm very happy about as a tech partner. But not only is it important to have these tools, you need to be able to document it. And MoldTrack software is a great piece of equipment to have in your shop, to where, you know, you might have achieved, you know, 60 or 32 thousandths buildup removed, and your GPMs might have gone up 13%, but you need to be able to document it and do it appropriately. The last thing you want is to have, you know, your guy that's PMing the tool is, you know, his job is to get it torn apart, clean, back together, moves on. If you don't know what he's doing, or if it's the same guy that's been repairing your tools for the last 25 years, he just knows all these tools in the back of his head. What happens when he retires and moves on? Now another guy comes in. Steve's software helps you track all the documentation, and he's got a nice tagging system, a stoplight system that shows, okay, this is red, like this has to be replaced. You know, green, good to go. It passes all the tolerances that you set up on whatever part that may be, whether it's an insert or a baffle or core pins, anything. And it's pretty cool software. It's very affordable. But I highly recommend checking him out if you get a chance. Now, while I'm doing this, Carolyn, if you want to pull up some of the Dropbox photos and maybe go to, can you go back off of that page? There we go. And scroll down till we see, oh, there's a lot of heat exchangers. Let's go through the all the tech. Yeah, the tech. Start at the top. The tech. Oh, that's the after, but that's fine. We can scroll through.
I see that. Okay.
So this is a cooling passage before, and I think you're gonna have to go backward. Go one spot before. There you go. And that's afterwards. Now, what you're seeing here is a secondary flush. So this particular customer, we flushed this tool for 2 hours once. They hung that tool back in the press, ran production, pulled it back out. This is what it looked like after the second time that we PM'd it. So maybe go forward to show some of the befores. Oh, that's an after. That's what it looked like before. And again, this is after they had flushed once, ran that tool into production, and then pulled it back out. Are there more befores on there, Carolyn? Go forward a couple. That was after. So the 17 and 16 matches up. So that's before on another cooling passage. You back up one. That's what it looked like after. So, you know, as little as 30,000 of buildup can affect your cooling and your channels by a great deal. So if you want to plug back to me, Carolyn, but the point of showing you that flushing after the second time, after the tool was put into production and came back out, is that the second time we jumped that entire mold. Most initial cleanings, your passages are really bad, so you have to focus on one or two at a time and really flush everything out to get it back down to bare metal. So there is a little bit of upfront time in making sure that your tools are cleaned in an optimum cooling condition. But your secondary and tertiary and future PMs, you'll be able to use jumper cables and flush all at once. So with that, we're gonna hook up to a mold now. Now this is a little bit smaller mold. For any of those of you who joined us late or recently, you know, we flush molds that are pretty large size. We've got an XL cart that does 28 gallons per minute. They can really flush out some larger tools. But the only reason this is smaller, I don't have a traditional shop here, so I don't have cranes and hoists to move around some big equipment. But this cart should handle most of the tooling out there unless you're doing some very large structural foam molding and just have to get through a ton of channels. So right now I'm hooked up. I've jumped one of my lines. Come back over here. Hook into pump, turn my check valve to pump. We slowly turn it on, and while I'm doing that, I'm checking for leaks as this pump, as the chemical works its way up there. You'd be surprised how many times you have a line jump off of you. That's some pretty nasty stuff coming back. But another important component, and I've had it happen to a couple of my customers. I know earlier I said, you know, you can safely walk away, and if there's a pressure buildup and blockage, it'll cease operation. And while that's fine to do, I don't recommend letting this run overnight. I don't recommend leaving it unattended for hours at a time. And that's solely because, you know, I had a guy that actually had a pre-existing hole that corroded closed. And he let the unit run, went home, came back the next day, 10 gallons of material on the floor. They weren't very happy, understandably so. You know, so I asked him to open it up and check to make sure that that wasn't pre-existing hole, which it was. But nevertheless, if you've got some older tools, you just want to keep an eye on it. So while you're free to roam around the shop, do some other things, or work on your PM, there are a few key things you want to watch. Obviously, do a visual check and make sure that it's not leaking anywhere or even outside your tools. You also want to do a visual check on the color of this chemical. This is kind of a translucent green. The other thing that you're doing as you're working around in the rest of your shop is you're listening for audio cues. So earlier when I was hooked up to that heat exchanger and recreated that pressure block, you heard the pump kind of slow down and the cavitation stopped. So visually or audibly, that should tell you when you're working elsewhere that there's a block in there. So you just want to kind of keep an eye on her. That tells you, hey, you need to pay a little bit more attention. Pay more attention to what you're doing just a little bit. But so what else? So now we've got this hooked up. I'm not going to flush this for an hour because I don't want you to just sit here seeing what I'm doing. But the point of it was showing you that you are able to jump your molds and clean everything out instead of having to do each individual circuit. But I do recommend on your initial cleanings, flushing out those circuits. So with that, again, I'm acting as if I've flushed for an hour or two. I pull my supply side, oops, I'm backwards. Let that chemical run through. Turn off my air supply. Swap the air over to the blowout. Again, the check valve on top. And I slowly turn that on until I see that air pocket come back to my drum. It should be right there. Now I can turn it on as much as I want to really get all that chemical out. And that's that. This is now where, if that tool is going back in production, you wouldn't necessarily have to worry about flushing it out with water. I will flush this out, but I won't make you guys sit through that. Now, this scenario is a pressure block situation. I have not yet cleared this. I've plumbed in here. Oh, I would focus more on, there you go. I've plumbed in the fittings that I want to use. Again, if this is something that you're going to work into your PM program, you can plumb in a T-ball valve like I have over there, but just to make it easier on myself. Hook up my return. Get my air. Hook up to my pump side. Can you see that? Okay. Check valve turns to pump. And then we slowly turn it on. Now, this is only going to allow me to pump so much, but I want you to hear how it'll cease operation due to the pressure buildup. You can see that I'm still getting the chemical in there, but that pump is now shut off. And you can kind of hear it give out a little bit. So when you do run into that situation, again, the point of this is showing you the safety feature of an air diaphragm pump versus an electrical pump. Electrical pump's just going to keep hammering liquid until probably that clamp comes loose, and then you've got caustic solution everywhere. So eventually, I do want pressure on it and the chemical that's in there to eat away at whatever's blocking. Now, these cooling channels happen to go halfway down, kind of in a semicircle before turning and coming back. This is flipped upside down for any extruders out there. But I do want that pressure up against the buildup. That way it starts to eat through. Then once I achieve flow, then we can, the pump will kick back on, and we want that flow. We want the chemical to eat everything that's around it. So this one will take a little bit of time, but I at least wanted to show you the pump in a pressure block situation. I'm gonna pan the camera back over to this feed section on this extrusion line. That way you can see, actually, Carolyn, I might have you pop in on the pressure release side. That way you can see what it looks like when we do need to relieve the pressure. And I'll turn the cart. In order to do that, we just relieve the pressure back into the drum. You can kind of see all that nasty gunk that came out of there. Could you see that?
Oh, yeah.
That's gross. But that's how you would do it. I get a lot of questions. Obviously, this is a newer carton chemical for us as of the last 2 years. But I do get a lot of questions about, you know, what does it do to some of the internal components to my tool? How does it affect O-rings? What steels can I use it on? What can I not use it on? So I just started doing all these time studies with my little jars, and I ordered a bunch of parts from PCS. This is just a brass plug, cover plug. I've had dipped in it since middle of March. So you can see it's kind of dulled that finish a little bit. It's no longer brass, it's just a darker finish. So by flushing with water, I'm removing that coating, and it'll help keep its color. Does that look okay, Carolyn? You know, there's a lot of beryllium copper. We'll run into some aluminum. I had to cut some of these pins. This is a core pin that I had to cut, but that's copper, so you can kind of see. And maybe if I put it on a dark backdrop, you can kind of see it. It's a little bit better. So it's darkened it a little bit. Again, this has been sitting in the EcoPro for now almost 5 months, 4.5 months. Some of our O-rings. Well, this chemical has kind of turned a little bit of different color. But these are your Builtin O-rings. How easy is that to see? Good. So they haven't broken down yet. I actually have a rubber hose insert for your cooling line. This is a neoprene O-ring. You know, everything's still intact. Now, I do have a hose insert because I get a lot of guys that ask, can I run this through my manifold and flush out everything at once? This is your typical water hose. Because over time, this stuff will break down rubber. Is that zoomed in, Carolyn? Can you see that okay?
Mm-hmm.
What I'm trying to show here is the lack of degradation on the inside of this standard water hose. Now on the exterior of it, it has started breaking down just a little bit.
And none of the O-rings were deforming?
No, I don't have any. I've got, let's see, silicone, PPDM. What else is over here? Builtin. Now, this is Builtin.
Mm-hmm.
So what you can see, it might be a little bit hard to see. I don't know where this zooms in. It looks like almost a crust-like layer on top of the O-ring, and it might actually be easier to see inside the jar. See how there's a little bit of crust forming at the bottom?
Mm-hmm.
I think that is a little bit of degradation of the surface of the seal interacting with the chemical, which I expect on some seals to break down. We were talking about that earlier, rubber, over the course of X amount of months. I just didn't know how many months. So it's good to know that these have been in for 4.5 months. They haven't broken down or, disintegrated or anything like that. But
They've been in there 4.5 months?
Yeah.
Yeah.
March of 17.
Yeah. How about silicone?
Oh, that's what I was, yeah. So that still has, I call it little chunks, kind of hard to see. But that's what these are. These are silicone. Oops, I just dropped it. So nothing's broken down on them. But pretty much all the seals that you'd run into in a closed mold. I just wanted to show, that I need to know how long it takes for them to disintegrate, whether it's, 2 years or 18 months, what have you. But we still tell people, because of you saw those alloys earlier, that it tends to darken the non-ferrous alloys over time. We still instruct people to backflush with water when you're done. Because I don't know, if somebody sends me a tool, We're not a traditional shop. I'm not tearing it apart. I have no idea what's on the inside of that. So I want to flush with water. That way I'm not staining any alloys that are on the inside. So what I don't want is people to be like, oh, well, this guy's, you know, none of his seals have broken down after 4 months. We're good. Just flush it and hang that tool. And then they pull it out and then the alloys are darkened after, you know, 3 weeks. So I want to get users used to back flushing with water, or else they're just going to get lazy and never do it. So thank you everybody for being part of our first ever virtual open house here with ID Additives, and hopefully you learned a little bit about what the EcoPro 360 can do, the various applications in which you can use it. Again, we're here to help, whether that's our foaming agents, our purging compound, EcoPro. If you need a resin supplier or color supplier, we're happy to do all of that. But again, please don't hesitate to reach out. I can't stress enough, staying safe, staying healthy. If you do need support, we're here virtually. And we want to help as best we can. So with that, don't forget to like and subscribe to our YouTube channel, and be on the lookout for many more exciting things to come from the ID team. Thanks, guys.